Okay, so let's talk about another type of exponential function called compound interest. And that's what that is when you interest on principal and on previously earned interest. So you're making money off what you put in and also the interest that's being earned. So it's a great way to make a lot of money. It's exponential, so if you want to get rich, you should learn about this. Anyway, just to remind, this is what it looks like. This is the formula for it, but it's really of that same form of all exponentials. You see how the y, the equals, the a is the p, the b is this right here, and the x is the n and the t. So it's very similar, okay? And actually, it may more resemble this exponential function that we're already used to seeing, the exponential decay and exponential growth, because it's really the same thing, except that well, more like the growth and decay, except that the only difference is instead of just having a rate, you have the rate divided by this n, and then you're also having a power to the n. But other than that, it's the same thing. You treat it the same way as an exponential growth. And so let me tell you what these stand for. The P stands for the principal. The principal. And what that is just like in the exponential growth and exponential decay and any exponential function, it's the initial amount that we start with. In money, when you start with initial amount, that's the principal. That's what the amount of money you start with. And after the principal, the R still stands for the rate. That hasn't changed. That's the in this case, it'll be the annual rate of interest earned. The N stands for the number of times the interest is compounded in a year. Okay, so that was what the N will stand for, and the T still stands for time, in this case of years. So this is the formula for compound interest. Let's go ahead and work one out. It says you deposit $100 that earns 6% annual interest compounded monthly, right, as a function. So we're going to take this formula and turn it into a function right now. So let's do that. Let's get this over a little bit so you can still see it. So y equals, now remember the principal is the initial amount. What was the initial amount we deposited? $100. Someone might easily do this. Someone could easily deposit $100 in a savings account and earn interest on it and let the money make the money, if that makes sense. So y equals 100, that takes the place of the p. 1 plus the rate. Well, the rate is 6%. Just remember that 6%, if you were to turn that to a decimal, you'd move the decimal 2 times. Right? 1, 2 place values. So it would be 0.06. But then it's divided by the number of times you take it out. Well, if it's taken out monthly, there's 12 months in a year, so we would divide that by 12. Remember that there's also a number of times up here, so that is also a 12. Not just down here, but also up here. And then the t is just the amount of years you do it for. Okay, well now we just need to work this out. So what is 0.06 divided by 12? You can get your calculators out and get the answer to that. It would be 0.005 if we were to work that out. So we'd have y equals 100, 1 plus 0.005, oops, to the t power. Well, then you need to just add the parentheses. So it would be y equals 1.005. I'll put the 12 up here. 12t. And that would be the formula. That would be the setup. If we were then wanting to graph this, we would just have to substitute different number of years for the t, and we can see how much money we're making. It'd be pretty cool. Okay, so let's work out another one, just to make sure we have this idea, if time allows. What if we were to take the exact same question we just did, would change the numbers. That would probably be the easiest way to go. So let's change the numbers here. We'll take the same question, but the initial amount will no longer be 100. We'll change the initial amount to 500. And the annual interest rate will be 9%. But otherwise, the question will be identical. So let's see what we get here. So I don't really even need to look at the question if I just keep those things in mind. The annual amount is 500. So we need to take the formula, though. That's what we do need. So y equals, now for the p, I'm going to put the initial amount, 500. 1 plus the rate is 9%. We saw earlier you convert that to a 0.09 divided by the number of times. Well, if we're taking the same questions, it's going to be 12. Right, and that's all to 12 being the n, and then the time. So let's get our calculator out. This time I'll actually get the calculator out so you can see it. So 0.09, let's see if I put an extra 0 on accident. 0.09 divided by 12 equals 0.0075. So we're going to add a 1 to that though, right? So it will be y equals 500 times 1.0075 to the 12th power times the amount of years. Okay. So that's the answer to this. But what if we wanted to graph this? What if we wanted to see how much that would $500 would make in 1 year, or 2 years, or 3 years? We just need to make a chart. X and f of x, or in this case we used a y, so I'll use a y, and substitute it in. So instead of a 12 there, we would have a 1. So y equals 500 is 1.0075, and then t, if t was a 1 there, 12 times 1 would just be 12. Okay, so now let's see what we get here. It's going to be a large number. It's okay. Calculator out. And we will do 1.0075 to the 12th power. And then we have 1.0938, and I'm going to times that by 500 now, doing the order of operations. Once we do the exponent, we multiply. And I have 546 roughly. That's a lot. 546. Okay, let's do the same thing quickly with 2 and see what we get. So if we were to put a 2 for the exponent, it would be 12 times 2 would be 24. So it would be 1.0075 to the 24th power, and then remember, after we do the powers, we multiply it. So let's see what our total will be. That's the y, the total. I'll do this quickly. So we would have 1.00075 xy to the 24th power times 500, and then we have 509. All that's left to do is to graph it. And we're out of time.